Okay, time to get started. We are all here according to my calculations or my taking record. Today's lab is going to be unique. It's a group project, and I think it should be a lot of fun. This stuff here I really don't need to go over. It's all stuff that we've already talked about. What you're going to be doing is exploring different things about electricity, some of which I talked about in class yesterday, some of which I didn't. But before we get started, I wanted to do one problem because I realized I gave you homework, but I didn't do any example problems. And it's, for some of you, been quite a while since you've done force problems where you have to add up the force vectors. And that's basically what we have for the homework, the actual problems, the last two. You got a question, Gabriel? Oh, yes. I posted the tutorial assignment. I called it HW00. You don't need to do that. It's not going to do you any good unless you don't remember how to use Expert TA, Jerry. So you don't have to do the homework 00. I just put it there so you could go through and get a refresher if you felt the need. So don't feel pressured. I've got to go through and put random answers and get things wrong and whatnot. It's not going to count towards your grade. Thank you for reminding me. Okay. One thing I want to do before we start is do a sample problem. So I've made a sample problem here where I have three charges, Q1, Q2, and Q3, which are conveniently enough. Q1 is 1 microcoulomb. Q2 is 2 microcoulombs. Q3 is minus, it looks much clearer on my screen than it does on that. Trust me, it's really bright here. Easy to see. I will change the color for you on that because, that didn't look so good. I'm just going to write over it. Q3 at 6.00 centimeters, 1.00 centimeters. Q3 is equal to minus 3.00 microcoulombs. Now it's just got pretty highlighted. Okay, so we have three charges in three positions. And the question there in black is, what is the net force on Q1? So let's start with the basics. We want to find the net force. What do I need to do if I'm going to find the net force? Just going through steps like we've done since the beginning of last semester. Okay, I need to draw a free body diagram. I need to identify the forces acting on my object and show them with their direction. So what is my object for the free body diagram? Q1, because it said, what's the net force on Q1, right? But we have to go through this because we could forget and say, I don't know. I got three charges and that's my whole, you have to identify what the object is. So on that object, I have Q2. Q2 is going to make a force. What direction will the force of Q2 on Q1 be? First of all, let's start with the basic. Is it attractive, repulsive, or otherwise? Repulsive. Why do you say repulsive?
Because they're both positive.
Because they're both the same sign. They're both positive. Right, I'm asking these questions not to make you feel bad, not to, but to make sure that we're thinking through the process. So it's going to be repulsive. So Q1 is being pushed away from Q2. So I have my first force arrow, like here. And then my second one, Q3. Is Q3 going to be an attractive or a repulsive force? Attractive because? Opposite signs and opposites attract. So it's going to be going like this. Now, of course, realistically, I would like my arrows to be roughly the right length, but I haven't done any calculations, so I don't know what the right lengths are. I just put the directions in there. So I will label these force of 2 on 1 and force of 3 on 1. So I have those two forces. I want to find the net force, so how do I find the net force? I do what? I add them up. They're vectors, so how do I add vectors? Okay, there are two ways. One is graphical and one is break them into components. For this case here, I think it's going to be easier to break it into components. So that's what I'm going to do. Sometimes it'll be easier graphically, but I don't think so in this case because I don't know those angles and I don't want to figure them out. So I'm going to break them into components. So to break them into components, I need to, number one, find the magnitude of each force. So let's find those magnitudes. So the magnitude of force 2-1, notice I dropped the vector sign because I'm just doing the magnitude, is equal to K, magnitude of charge 1, magnitude of charge 2, over R12 squared. That's just our Coulomb's law equation. So I put numbers in as much as I can. K is a constant that's 8.988 times 10 to the 9th Newton meters squared per Coulomb squared. I forgot to even say that number, I think, in class yesterday. So I have my K value, and then I need my two Qs. So Q1, 1.00 microcoulombs. What does micro mean? 10 to the minus. Our recording is going to be worthless. Screencastify dropped 82 seconds worth of audio. That's more than a minute. What did you say for the answer?
I got 7.1904. This would be newtons, right?
No times 10 to anything. Well, I mean, I didn't do the math. 9 minus 6 minus 6 is minus 3 divided by minus 3. It seems right.
Yeah. So it's probably just
Okay, so I have the magnitude. I'm going to go ahead and calculate the magnitude of the other force, and then I'll worry about getting the vectors. So the other force was force of 3 on 1. Notice it's Q1 still because I'm looking at charge 1, and Q3 because now I'm looking at charge 3. Okay, now charge 3 was minus 3 microcoulombs. So what I put here? I don't put the minus sign because I'm just doing magnitudes. We have to remember when we say we're just doing magnitudes that we're really just doing magnitudes and not throw in the minus sign anyhow. And those numbers were 6 and 1. And my trusty Jonathan.
7.288.
0.
No, sorry. 2876 actually.
2876. Now, granted, how many significant digits do I have? 3. And so I'm putting 2 extra digits just to make sure I don't drop something. Okay, so I have the 2 magnitudes. Now I need to add them, but I need to break them in components to add them. And so, how do we break things into components? I know the magnitudes of each one of these. How do I break into components? Okay, sine and cosine. So if I want notice I have x marked already. If I want the x component of force 1, 2, or 2, 1, excuse me, let's define an angle. So I'll call that theta 2. Which trigonometric sign or function would I use to find the x component? Which one? There's really only two possible answers. Cosine, because it's the adjacent side to that angle. So what's the definition of cosine for a right triangle? It's blank over blank. Adjacent over hypotenuse. I'm going to find cosine of theta 2 directly. I'm not going to even worry about finding the angle in between. I'm just going to take this and say cosine of theta 2 is equal to the adjacent side. Well, going from this point to this point, the part that's going this direction is 3 centimeters. So that's equal to 3.00 centimeters divided by the hypotenuse, which is 3 squared plus 4 squared square rooted. We could all do that in our heads. So cosine of theta 2 is 3/5. And so I can come down here and say force 2 on vector is equal to, is that in the plus or minus direction for x? Minus. Now I got it. I can't use green here because then it'll get confused with the one below it. So going to blue. So it's going to be minus 3/5 is 0.6. I'll just put 3/5. Minus 3/5 times 7.1904 newtons in the x direction. In the y direction, is it going to be positive or negative? Negative, so I'll put a minus there. Minus. And if I go the other way, opposite side is 4. So it's going to be 4/5. So there I have my x and y components, which I need to move this down. Well, that didn't quite work out. So what are the actual values for the x and y components?
X is 4.314.
Definition